I'm going to talk about inheritance, and I took it from this great tutorial here on the W3 Schools site, and I just kind of elaborated a little bit more on what they're doing, including a diagram, a class diagram that, excuse me, shows the parent class and the children classes. Sorry. And of course, I took it a step further just to kind of point out and exaggerate some points that I think need to be further emphasized. So let's take a look at our class, our person class, and notice that even in our diagram, we've added those details. We've added that the person class needs to have two properties, the F name and the L name, and it also has further has the output method, the output first name, and the output last name. And also it can be called a base class or it can be called a parent class. And that's why student and special student and graduating student and professor, they all point back to their base class or their parent class. And these are normally called child classes or children. Okay, so notice that the base class does not inherit from anybody, and also in Python sometimes even a base class will inherit from the object class. Now that's probably newer in Python, but you can still see code like this, or sometimes they'll say, well, we want it all to inherit from one, kind of like super primitive object class, and I've seen that also. And there it is, the comment, the most based type. So you could do that, and but in any case, we still consider the person class really the base class, but then it could also have a base class of object. Okay. For our stuff, that isn't necessary, so I'm taking that guy out. Okay. After that, notice that every class we define after that is inherits from the person class. So the student class inherits from the person class, the special student from the person class, the graduating student from the person class, and finally the professor also from the person class. And that's how we get our arrows pointing back to the base class in our diagram. Okay, I'm going to get rid of our diagram just to give us a little bit more space, real estate on the screen. Boom. All right. And now notice that we have defined our constructor or init statement method, and notice that every method in a class needs to start with the word self. Okay, and that and that's just the way it is, guys. It's just you need to have that word self in there. And so notice that the output method name also has self, even though it doesn't have any other parameters. And so does output first name and output last name. They all have the parameter of self in there, which just refers to the object itself. Okay, and then finally it has the parameters first and the parameters last, which are going to be used to initialize our instance variables f name and last name and L name, which are actually in our diagram. Okay, output name, first name, and last name do not have any parameters that the person actually sends to it. So that's why all you have is the word self, and we're done with the base class. That's all the definition we have to do there. And of course, each one of these prints what it's being asked to print. So if it's output name, it's going to print the first name and then last name. If it's output first name, it will just print the F name. And if it's output last name, it will only print the L name. Okay. Finally, or firstly, I guess, the student takes the base class and all its properties and all its methods and basically does nothing else. So in order for us to declare that a student is exactly the same as a person and it's not going to modify or need any other methods or do any other properties, all we have to do is declare the body of the student class as passed. Okay. and we're done. So we didn't have to write those 3 methods and those 2 properties. That was all just contained in person, and we just inherit from person all that functionality. But let's say that for some reason we have a special student, and that's a grad student, and we want to use the word grad in front of his name just to distinguish that when we print out his first name or first name and last name. And so we need to in some way customize our init, our constructor. So how can we do that? Well, there is a way to do that only for special students, and so we inherit everything that the person does, but when it comes to the constructor, we're actually going to rewrite the constructor and so that we can have a custom first name. And so that's exactly what we've done here is we take the init constructor, we define it again. The first parameter is going to be self, and then it's going to have a first name parameter and last name parameter. And we're going to take that first name parameter and add the word grad in front of it, prefix it with that, and then make that our custom first name. And then we're going to pass in our custom first name to the base class's init constructor so that it can initialize the L name parameter and the F name parameter for us. And ta-da! That's all we need to do. And now special student still has the L name parameter, the F name parameter, and the 3 methods of the person, but it customized the init constructor how it needed it so that we could include the grad in front of the first name. But let's say we wanted to be a little bit, and we needed something else for graduating students, because with graduating students, we need to know when their grad date is going to be. So, so we can actually, instead of overriding our init state, our constructor, we're actually going to create a different constructor. And so what's going to be different about this is it's actually going to require 3 parameters instead of 2 parameters. And so, you say, well, what's going to happen to the 2 parameter version? Well, it's really getting, in a way, it's not being overwritten, but overloaded, but it's being overwritten. And instead, we're going to have a valid 3 parameter constructor instead of the 2 parameter constructor that we had with person. And so we might be tempted to do something like this. We might be tempted to actually initialize the F name and the L name properties. And that would be okay, but the problem is, by doing that, we would effectively not have to call the base class constructor. And then if we fail to do that, we might unfortunately cause a problem, because in a way, if we have a constructor, we probably should call it, because the constructor kind of tells you, hey, this is in the beginning of this object. We really want the constructor to do something special. And so we're kind of going around our own helpfulness and possibly duplicating code, and so what we end up doing is doing the same redundant code in 2 different places. Now we got 2 different places to worry about. We're making a mess. So instead of making a mess, we can call the base class again, base class's constructor, with the first parameter and the last parameter, and then go ahead and initialize our new property. And this is probably the better way to do it. That way our code is assigned only once in the base class, and then our new property gets assigned thereafter. Okay, so everybody's happy and no more code confusion. Okay, so let me point out what I have here on lines 51 through 53 in a comment. That that is really, if you have written line 53, it would be invalid because it only requires two parameters and it's not passing in that grad date. So that would be invalid. It actually causes syntax error in Python. Okay, but what would be valid, sorry, would be a 3-parameter constructor call to graduating student with the first name, the last name, and the graduating year. That would be valid, and that's exactly what we wrote up there. All right, and finally, the last case they want to look at, we have changed the init constructor, and we went through 2 different versions of that. But could we do the same for our methods? And in Python, absolutely, that would be a yes. We could override the functionality of our methods. So in our professor class, we're going to keep the init constructor exactly the same as the person's, but we want to change the output. We want to change what is being outputted from the output first name and output last name, because we want to tack on the word professor in front of it. In fact, we want to use some formality, so when we output the first name, you always get professor first name and last name, and when we output the last name, you get the phrase professor and then last name. So we just did that so we can show that we can override the internal functionality of those methods just for our professor. Okay, so notice our person will remain the same. In fact, all the other classes that we have defined, they will remain the same, and only for professor objects will we have the output first name add the word professor in front of it. Okay. So, and that's about it. I mean, obviously, this is incredibly powerful if you have a large hierarchy and different types do slightly different things, or maybe even greatly different things for the same functionality. And so there's a lot of power behind using these object-oriented techniques. Okay. Now let me take out this breakpoint from here, and notice that now we can start creating objects, and that's what we're going to do. We're going to create a person object, a student object, a special student object, a graduating student object that requires, of course, 3 parameters, and a professor object, and then we will call each of those guys output first name. And that's the power of that, because notice that even though we have different objects, that one is a person object and the other one is a student object and a special student and a graduating student and then a professor student, they all have an output called output first name. And of course, just because we can invoke the programmers are lazy rule, we could actually put all those objects in a list, in our object list, and we could actually not have to do all of those 5 statements that we did from line 80 through 84, and we can make it a simple for loop and then print basically call the output last name on all those objects, because all those have that object, because they all inherited from the person object, which is really cool. And that's the reason why that's another reason why you would want to do that, because Python has this way of programming that says if it quacks like a duck and it walks like a duck, it's probably a duck, and so all these different objects all inherit off from person, and so in person have that output first name or output last name method, so you can be assured that by doing this you're not going to break any rules and it's not going to cause a syntax error. And so when you run this down here, that's what you end up getting. You get up getting the first names of everybody, including the grad Carl and the professor Ed Tesla, and then when you print out all the last names, you get what you're expecting, including Professor Tesla at the bottom. Now, let's do something interesting. Let's say you just wanted to understand what's really going on. One of the powerful features of Visual Studio Code is using the debugging version of this. So if I hit F5, I'm going to hit my breakpoint that I just set on line 72. And notice that on the left-hand side, I can see all my variables. And so when I do an F11 and step into the construction of this class person, I can see that it's going to create an FName property and an LName property. And I come back to here, and if I open up P, the variable, I will see a FName of Adam and a LName of Ford. And if I do that same thing for student, not surprisingly, it's going to go back to the person's init constructor, because remember, student has no init constructor of its own, but it can use the person's init constructor. It will do the same thing, and voila, check out the student, and it has the FName Bob and the LName Chevy. Now we get to the special student, and what is it going to do? Well, it's going to call its own custom constructor, and then in the custom constructor, it will make a custom FName, and you see that on the left hand side there, grad Carl. And then if you hit F10 one more time, it goes where it needs to go, which is the person init constructor. It creates the FName and it creates the LName. Ta-da! And again, if you look at the variable SS, not surprisingly, it's going to have an FName of grad Carl and LName of motors. Finally, no, not finally, but going into the grad student, you hit an F11 there, and of course it goes to the grad students, and let me scroll up a little bit, the graduating students init constructor, which calls the parent constructor first, F11, then it does the FName, it does the LName, and then it adds one more thing, which is the grad date, which is the year. And we can see that here on the left hand side, that GS is now equal to, there's the FName, there's the LName, and there's the grad date. And finally, for our professor, F11, again, notice that because it doesn't have its own init constructor, it's got to jump back to the person constructor. Ta-da, ta-da, and we can open that guy up. And notice that yes, it has that correctly outputted. And so it is no surprise that these guys will do the right thing. If we hit F10 at this point, at line 79, of course, it's going to print out the first name of each object. And we're going to skip most of these until we get to the professor one, and we're going to hit F11 at this point, and we're going to jump into there, and we're going to notice that it's going to hit on the override one, so that it can add the word professor to the LName, to the FName, and to the LName, and that's why we get Professor Ed Tesla. And in fact, now we're on line 88 after we've done that, and we create a list of objects. So what does that look like? Let's click on the left hand side, click on the little arrow on the side, and notice that it really is our person and our student and our special student and our graduating student and our professor objects. And then we can click on one of those, and we can see that the first name of the first object is Adam, and the last name is Ford, and we open up the next one, and the student is Bob and Chevy, and the next one is grad Carl and motors. And really, I love this debugger because you can really kind of drill down into the different values of everything. Finally, we're going to step down past into our for loop, and notice that anyone becomes the first object in our list. So let's take a look on the left hand side, and oops, anyone, here it is. anyone. And of course, it is Adam and Ford. So when it outputs the last name, of course, we're expecting it to print Ford. And it does that. And then it goes on to the next object, which is Bob and Chevy, which is a student. And guess what? It's going to print out Chevy. And then it's going to go on to the next one, and now it's going to be grad Carl and Motors, and of course it's going to print out Motors. And of course we're going to go on to the next one, and it says David and Dodge. And let me scroll this down a little bit so we can keep a track of that. And finally, it's going to print that out. And finally, it's going to be Ed and Tesla, and we're going to step into this one here. And notice that it's going to call, what are we expecting it to call? We're expecting it to call the professor's output last name. So we're let's see if that's true. We're going to hit F11, and sure enough, if we scroll up just a little bit, we notice that we're in the class professor, and we have overwritten the output last name, and that's exactly where we need it to be. And it's going to print professor and then L name, which is Tesla. And we hit F10, and we're back to our for loop, and then we're going to be done with our for loop and done with our program and done with our output, and we're done with the tutorial. So I hope you appreciate all this fun and hard work, and I hope you enjoy programming and using inheritance in your programs. And there's a lot of power behind it, a lot of code saving, and when you save code, that means you don't have to test that code. That means you don't have to spend time in that code. That means you get to go home early, and that's a good thing. All right? Have a great one. Bye. Hey, so if you like this video, please click subscribe, and I specifically encourage people to ask questions, ask detailed questions, and I'll do another one of these videos for you. I believe that programming is not as easy as you think it is, and we sometimes struggle. So I'm here to help you guys. I will go into the excruciating detail that you need to comprehend as much as you need to comprehend so you can get to the next level. All right? So I'm here to help you. Remember to subscribe, ask a lot of questions, and I'll get back to you. Thanks.